Welcome to No Diagnostic Required, the companion show to the C++ Annotated newsletter. I'm Phil Nash, developer advocate at JetBrains. I'm joined by my co-host, Anastasia Kazakova, and we're going to be rounding up some of the news from the C++ community this month in February, but it seemed like we only just recorded the last episode. How does that work?
Maybe just a short month?
It is a bit shorter, yeah, but also I think we were a little bit late last time, so it was only just over 3 weeks ago we last recorded, although, the way things have been going the last year, everything seems to be a bit compressed, I think. Still, there's no shortage of news to cover this month. In fact, starting a bit closer to home on the JetBrains front, Anastasia, do you want to tell us about the developer ecosystem survey?
Yeah, that's more like a small ad in the beginning. So before we start with the news, so I would like to encourage everyone to fill out our annual developer ecosystem survey. So actually every year we run an extensive survey on the IT communities all over the world and collect lots of information. And later we'll share the results and the raw data with the whole community. So you'll have an access to it. And you now have a chance to win an incredible prize for filling it out and even receive personalized survey results to compare yourself to other developers in the world. So please help us gather insights about trends in the C++ community.
Yeah, I always look forward to the results of these surveys. They really do shed a lot of light on some interesting areas, so do help out by filling that out. That will help yourself as well, of course. So then we move on to our sort of usual C++ standards news about the committee and what they're up to. So this month we did have, as I said last month, we've moved to monthly mailings now. So the mailings that usually go out just before or just after a committee meeting when they're having every month. We'll get to that in a moment. But this month we also had a plenary session. So usually at a committee meeting, the end of the week, the whole of the committee will get together to actually vote on what's going to be adopted into the draft standard. And we didn't have those for most of last year, once everything moved online with the pandemic. But just towards the end of the year, we did mention this, I think, in the first episode, they started doing plenary sessions again online. And we had the second one just this week, in fact. So this is breaking news, really. And as usual, Herb Sutter, of course, has written up an excellent trip report. It's amusingly called a trip report. We didn't actually go anywhere, but it's covering sort of highlights of what, from Herb's perspective at least, are the highlights of what went into to the standard this week. So just having a look at some of the things that Herb picked out that were interesting was starting with P1102. In fact, all of these proposals we're going to mention are all really very small things. They're mostly sort of fixes or tweaks that just sort of make things a little bit more consistent and maybe simplify things or fix an actual problem that was there. And this one has been around since C++ 11, really. And Herb partially blames himself because he came up with the original syntax. But his intention was that all of the extra brackets and things that make up C++ lambda syntax should be optional where it's not needed, except for the square brackets, which form the lambda introducer. But you may or may not know that if you don't actually have a parameter list, you can usually omit that and just go straight into the to the curly brackets for the body of the lambda. And of course, you can omit the return type as well. There was a little exception to that, though, which made things a little bit not quite as nice, which is if the lambda needs to be mutable, you put the mutable keyword there, because they did actually get the defaults right on this occasion. Lambdas are const by default, as in anything that gets captured in a lambda is effectively const. But if you want to be able to change it, you have to put the mutable keyword there. And according to C++ 11 rules, right up to C++ 20, once you put that mutable keyword there, then you can't omit those empty braces anymore, empty parentheses rather. So the example I'm showing here, the mutable keyword is highlighted red because we haven't put the empty parentheses. As of C++ 23 now, thanks to P1102, you can do that. A little thing, but it's something that just makes things a bit more consistent and a bit nicer to work with. And there are a few of those. Some of the others that Herb highlighted, which I won't go into in detail, P2212 to do with time point clocks, greater flexibility. P2162 to do with cleaning up stud visit, so that's still being worked on. Quite a few of these little fixes and tweaks have gone in this week. Nothing major, so some people may be a little bit disappointed that we are only working on these small fixes and tweaks. I think that's a good thing in general, because we've had a really big release in C++20. We actually need to spend a bit of time cleaning things up, I think. And if we don't get too many big features in C++23, maybe that's not such a bad thing. That doesn't mean that we're not still working on them, though. And in fact, we'll look in a moment at some of the things that are being worked on. But final thing I want to mention from the Herbstrip report was mention of something that didn't get in, P0533, which is all about adding constexpr to as much of the maths library in maths.h as possible. Sure seemed like a good idea. Everyone's really in favour of it, but there were a few edge cases that made people a bit uncomfortable about putting it in at this stage without a bit more time to think about some of these thorny issues, like how to deal with no in a constexpr context. And I know that there was also some discussion about how floating point precision in doubles will be handled, because some of that's platform specific, which means you'll get a different result if it's evaluated at compile time versus runtime. So this all needs to be weighed up before that can really be rolled out. So doesn't mean it won't make it into 23, just means it didn't make it into this plenary. So that's still being worked on as well. So I mentioned the mailing that went out. So this is all the papers that were discussed as part of the proceedings leading up to the plenary. And does actually, well, it's actually quite a long list. I haven't captured it all here, but a couple of things I want to bring out are a couple of papers, both from Victor Zerevich, relating to stud format, which is, of course, Victor's library that got adopted into C++20. And like a lot of things that got into 20, some fairly big, fascinating features, but only the minimal form made it into 20. And 23 is seeing a lot of these things now being sort of more fleshed out. So stud format, the few fixes to do with performance and other little things again there. But one of the nicer things that I'm really pleased to see being discussed is compile time checks for the formatting expressions. Because the strings are, or the string literals are compile time constants now, they can actually be evaluated at compile time. And if there's an error in that formatting, like in the example shown here, where you're passing a string where a number is expected, as a C++20, that would actually throw a runtime error, a runtime exception. But in with this proposal is accepted, that's going to be a compiler error, which is just better all around, really. If you can do it at compile time, why not? It's one of the most interesting parts of Victor's library, which you can still use separately from C++20. Has had this feature for a while. So really pleased to see that being discussed. I say this is one of the papers that's not been adopted yet. This is still being discussed, but I'm pretty confident that's going to make it in at some point. And then the last paper that I want to mention, it's not actually a proposal for a language or library feature at all. It is more of a sort of a broad-ranging discussion, really, from Bjarne Straustrup. C++, an invisible foundation of everything. And this is really an answer to the question of, what is C++ actually for now, and what was it originally for when it was originally conceived? And who better to write that, of course, than Bjarne? So in just a few pages, very succinctly, he's managed to capture that sort of history and evolution of C++ as a language in terms of what it's actually for, what it's best at, what its core tenets are, and how that's evolved through time, places where it's not quite always lived up to that, and what we're doing about it, where it's going in the future, and why Bjarne thinks that it's going to be relevant for a long time to come, and definitely worth continuing with. So really interesting read, not actually that long. It's 9 pages, I think, here, but as he says in the intro, the version that's published in the ACCU Overload magazine It's just 4 pages, so definitely worth a read. And that's all I really want to bring out from the Standards Committee news this month. So I'm going to hand back to Anastasia to talk about concepts.
Yeah, thank you, Phil. Actually, a very nice paper by Bjarne, I would say. And I think everyone in C++ world, those who are skeptical about the language and those who are happy with the language should actually check it out and catch some nice things mentioned there. So I really enjoyed that. And so now let's talk about this concept library. Actually, it's called More Concepts, and I do think it's a very interesting library. So it's actually intended to help categorize the STL containers and write some generic code that works with the selected category. And I'll give you here an example. Assume I want to write a code that accepts any container that allows mutable iteration, for example, which is everything except set. Or as another example, a container that knows its size, like everything except forward list. So what should I use? And this library is actually an answer. So you can see what is there. So there are several parts, I would say headers in this library, like base containers, concepts like can be cleared or allows reverse iteration or knows its size, and so on and so forth. Also, there is sequence container concepts, and probably my favorite here is a random access sequence container stored continuously in memory. Associative container concepts say to cover map and a NORNet map, like unique map container and others. So a very interesting library, I would say. And there are also some wrappers over standard type traits and mock iterator class template to create your own specific concepts. And yes, you might ask, do you really need all these specific concepts, conditions as a library? So maybe not as a standard one, but why not to have a nice open source library which actually can help with such patterns? Just need to track their no redundancies, for example. But yeah, in general, I think it's a very nice library, at least to check it out and to see if you can, sort out all these containers in your head in terms of the concepts. So yeah, that's about this library.
Well, I want to actually slightly contradict you there and say I think most of this should actually be in the standard. Maybe not all of it, but a lot of the more fundamental stuff, really that's the whole idea behind concepts in the first place. And in fact, concepts, they've been around as an idea for a very long time, at least a couple of decades, but it was one of the things that actually slowed down getting to C++ 11, why we had such a long period between C++ 98 and 11, because a lot of work went into concepts, which were actually much more complicated or sophisticated, should I say, than they are even today. And then they wanted to build on top of that and sort of run it through the whole of the standard library. Everything was now based on concepts and had concepts baked into them. And then at some point, they realized they needed to pull concept out. And then that had to come out of all of those other places that it had touched. So I think you can understand them being a little bit conservative on the first attempt at getting it actually into the standard, knowing that, like we said before, a lot of these things, they're going to be rounded out, fleshed out a bit more in the future standards. Hopefully we'll see more of this in 23 as well. But for now, yeah, you can certainly use it in a library, and libraries, external libraries are great playgrounds for these things based on new features where we're really still exploring that design space a bit. I do hope a lot of that's going to get into the standard in the near future.
I would say yes and no. I mostly agree, but I'm kind of conservative here. I just don't want everyone just to put their own concepts, very specific one, into the standards. So just keep calm. Just don't put everything into the standard. Yeah, that should be just a fruitful move. But yeah, in general, you're probably right. Yeah.
Yeah, there are 2 types covered here, but when I look through briefly, there are a few that look pretty fundamental that I think should really be in standard. Okay, so next topic is C++ 20 module support in build 2. Do you want to talk to us about this one?
Yeah, we actually talked about the model support in Microsoft ecosystem a while ago, and now it's time to talk about the others. So while you probably know that CMake is still not yet there, the Build 2 has announced some support for C++20 models, which is actually nice. And yeah, there's this nice article written by the author of the Build 2. So if you haven't heard about the Build 2, this kind of an open source build toolchain, which consists of the build system, a package manager, and a project manager. And now it's announced to support C++20 models. So when you use them with GCC. And this is actually a very interesting move. And like to get the most flexible solution, Build 2 simply discovers model and header unit dependencies and communicates their mapping to the compiler. And there is a nice Reddit thread actually, and the user spotted some weak points of the architecture there, I would say. So like a long thread discussing the decision to make any extension fit in the model interface. So should we use a single extension that everyone uses or accept all like Build 2? Actually, a good question, I would say. So feel free to join the discussion there. But what I personally found quite interesting in this article, in addition to the main use about the model support, is actually a library of basic C++20 model examples to illustrate how they can be used with Build 2. So from a minimal example of like names model consists of just like 3 files to header units and automatic on-the-fly translation of include directives to import declarations. So I would say just a nice library of examples for you to play with, which is actually a cool thing. So yeah, get your hands on it and play with examples. So I think I played with them for a while just because they're nice examples of the models, some, real things to try out, because I don't think we have lots of examples for now. So while we are moving to these C++ models slowly right now, but practically we don't really use them. I don't know about you, Phil. Have you played with something in models?
Actually, I've only really used them so far to put together, I think, a demo for one of the What's New videos a little while ago. So I know my previous role, I was really waiting for modules to solve a load of our problems. And I know lots of people have been waiting for modules to solve all of their problems. And it still remains to be seen how many problems they're really going to solve. But certainly, as support rolls out in different compilers and build tools, and we get good examples like these that actually show us how we might actually use them, people will start using them and finding these things out. So it's still early days for modules, but I'm still hopeful that we're going to see some of the benefits that have been promised all this time.
Yeah, we probably need a model which returns 42, just in case.
Well, that would be the ultimate answer, obviously. The other thing I took from this is that, as you say, CMake still not currently supporting it. If you do want to play with it, Build 2 is a good build tool to actually try out. We don't have built-in support for Build 2 in CLion at the moment, but I did do a What's New video a little while ago. I'll dig out a link for that, where I did use Build 2 as an example of how we can support third-party build tools by using some of the integrations that we have. So I'll put a link to that in the notes. In the meantime, talking of tools, Clang Power Tools has a bit of news this month. Do you want to tell us about that, Anastasia?
Yeah, I actually heard about that in CPPcast, and I was actually quite happily surprised with that. Like, first of all, the Clang Power Tools is it's an extension for Visual Studio C++ developers, but not only right now. And the big deal is that they moved to the completely free model, so even for commercial use. But I was mostly interested not in the things that they bring to Visual Studio, like the Clang tidy and LSVM static analysis checks, but also in what they done in terms of the Clang format editor and the format detector, which is actually a completely new tool, and that's a standalone tool, so that has nothing to do with the Visual Studio, so you can just run it on its own. And an interesting thing is that we did that in the past as part of the hackathon project in JetBrains when we were trying to extract some known predefined code styles. And that's what exactly this style detector is doing for you. So you can actually grab a whole directory of sources, open it in this style detector, and ask it to detect the code style. And it will extract the Clang format options from it, and it will present it to you nicely in this kind of the UI, so you can tune some options, see some differences between the code, how it updates when you change some parameters, and then actually save it as a Clang format config and use it further in your project, which I think is actually great. So if you start with some code base and you want to keep the style, but you don't know which style was actually used there while the code base was created, that's a good way to move forward. So you just extract the style and then save it as a Clang format, which is kind of default for C++ community for now. And then, then you can proceed with the project with this extracted code style. So and all these tools are now free for everyone, including commercial use, and they are open source at GitHub. So I think that's a good point where you can start with them, and a very nice tool to play with the Clang format. If you haven't before, just go grab it and play, I would say.
Yeah, that style detector is pretty impressive stuff, but I'm pretty sure it will completely break on my code.
That's actually interesting just to see how it works, because when we were extracting the code with our hackathon project, and that was a long time ago, I think, and that was the time when the first predefined code style actually appeared in CLion. I think it was a Google style, and we were extracting it with our hackathon project, which was doing exactly the very same thing, which is done by the style detector. I think we were okay with the Google style and LLVM code style, but then we tried to extract the Bjarne-Stroustrup style. And then we were completely breaking the things, because Bjarne is actually, while he states there is some code style, he's usually breaking his own code style in his own code quite often. So the detector just was completely broken by that. So would be interesting to see how your experiments goes with the Clang Power tools.
Yeah, well, what does Bjarne know about C++ anyway?
I would assume quite a lot.
Funny enough, one of Bjarne's proposals in recent years was uniform function call syntax. That's going to come up in a moment. So let's talk about postfix completion in CLion. Talk to us about this.
Yeah, I would be happy to. So we just brought the postfix completion for C and C++ to CLion EAP for the next version, 2021.1. So actually, coding is a truly creative process, which usually starts with an idea, and then you have to code it somehow in a proper way in the selected language. And an IDE, it actually can help you with the coding. So it can't help you with the idea. It can with IntelliJ IDEA, but not with the idea for the code. And then it can assist with the language constructs that are coming next. And actually, they can be indeed coming next. What I mean here is that postfix completion lets you add the code around the expression you've just typed. And the way you do it is that you just type the dot and then select, for example, some template from the completion list, or you can use it also to wrap your expression as a first argument of a free function. So say you can, for example, type dot not and then get to negate the already typed expression, or wrap with the C++ style cast, or with a for loop, or with the make shared or make unique, or some begin end idioms, whatever. So there are lots of predefined templates for C and C++, which are already available in CLion. And actually, we have these for a while in ReSharper C++ as well. And it's not just about the predefined template. So you can also type an expression first, but later pass it to a free function as a first argument by simply typing a dot and a function name and selecting a free function from the completion list. And it actually even takes the argument-dependent lookup into account. So I think that's really cool. I don't know. How do you feel about that?
This is something I've been looking forward to for a long time, ever since I first saw it in ReSharper C++. So I was quite excited about it when it was announced, and I mentioned it on Twitter. And I just to be cheeky, dropped in a reference to a uniform function call syntax there, because in a way you can use it as a workaround for not having uniform function call syntax. So what I mean by that is UFCS is this idea where you can call any free function that takes the object as its first argument as if it was a method. So if you have, say, you create some new function that takes a string, let's say parse, might be an example. You can then do like s for your string dot parse, and it will call the function and pass the string as the first argument. So really useful, but it turns out to be quite controversial as well. Lots of really heated discussion from both sides every time it's come up. So it's been a bit dead for a while in terms of an actual real proposal, but there's definitely lots of people that would really like something like that. And the reason this is relevant is that postfix completion gives you most of the benefits of uniform function call syntax without that controversial part. So this may actually be as close as we get to it. So I'm definitely quite excited about that. And there was definitely a bit of a discussion stirred up on Twitter when I mentioned it there.
Yeah, it was indeed. Like I've heard actually a couple of negative arguments for postfix completion from our users who were saying, for example, that, yeah, that's the way to forget the proper syntax, for example. But like, yeah, you have plenty of ways to forget the proper syntax, not just the postfix completion, you know.
Yeah, you get those complaints just about code completion in general. So
yeah, just stop using the IDE. It helps too much. That's true. Yeah, but I think that's a fantastic like productivity feature when you actually can start with the idea and then get the rest just automatically after the dot. Yeah, that's nice.
I think it actually may even go further. Obviously, for most people, it just seems like a convenience. But for people who are designing libraries, people often make a choice to add things as methods that maybe they feel shouldn't be, simply because they want it to become ergonomic for developers who are using IDEs for code completion. And if they know that many of the most popular IDEs out there now support postfix completions, then maybe they'll actually design their libraries differently in a more well-structured way. So this may actually be a good thing there for second and third order effects as well.
Yeah, let's hope for the best.
Yeah. Okay, so next thing to talk about is the C and C++ search extension. What's that all about then?
Yeah, just another tool in the pocket. So, and this is something you should have installed if you're a C++ developer and use Chrome, Firefox, or Edge, believe me. And like, let me just explain how it works and what it does for you. A very short task, but it does it perfectly. So I think many of us usually search the CPP reference for like some function or for the header if you're looking something in the language. And do you know you can do that right from the address bar of your browser? So you just type the CC and then the request, and this extension actually helps you with that. Or you can do the CC : header name and read through the content of the selected library header, which I think is impressive. I was recently, checking Chrome in the Chrome. In my Chrome browser, the concept header, and was playing with some others like Krona, and I think I just read a few extras just to play with the extensions, going through the headers. And they actually recently added the multiple language search. So you probably know that CPP reference is not just in English, so you can read it in other languages as well. And also they added a new command, which is :POSIX, to show you all the POSIX system interfaces, which I also think is kind of impressive. So you can search through so many things right from your browser. And I really love the extension. I think you should get it and maybe even contribute and get more handy comments into it.
Interesting anecdote. Sometimes sat in on standards committee meetings, and you had the people there who are actually defining the standard, discussing, and sometimes some point will come up and somebody's not quite sure what the current state is, and you would expect them to say, well, the standard says this. But I was quite surprised a number of times they'll say, yeah, but CPP reference says this.
Yeah, given it just a wiki, it's not an official standard or something. They're just some wiki pages. But we do treat CPP reference as a standard, because when you do search for the header or for a function, you don't go to the actual standard paper. Like, let's be honest here. So we check it, but for very deep details, yes, we do. But if we want just to learn, for example, the new header, I usually go to CPP reference to check what's there. So, and they are updated quite nicely, and they can show you the standard, so you can learn like, yeah, this is like since this standard and this is until this standard, so you can see how the things evolve. And I think this is great. So very useful resource, and it's nice that you can now search it right through your address bar in your browser.
Yeah, it's definitely more accessible than the standard itself.
True.
The only downside to this extension is it's not available in Safari.
Yeah.
Which is my usual browser. Now, if you do use Safari, you may actually be surprised by that, because one of the things that's changed recently is that it's now very easy to port Chrome extensions into Safari. So I looked into this, and apparently it's because it relies on a particular extension API, the Omnibox API, the bit that actually gives you access to that box at the top. And that's something that Safari doesn't expose. And some other search engines, like the Rust search extension, has the same issue for the same reason. So it's probably not going to come to Safari either for that reason. But yeah, plenty of other browsers do support it, so you can.
Yeah, and you actually mentioned a very good thing, that this pack of extensions, it's not only about C and C++. They have other languages on board, like Rust, for example. So, and you can search through the relevant resources for other languages as well. So if you're not just about C and C++.
Yeah. Okay, so for some reason that's moving on. There we go. Finally, and the final in there is a bit of a pun. How do you devirtualize a call, or how does your compiler devirtualize a call? Something you may have wondered, or maybe not. Maybe you should, because these are the sorts of optimizations that we rely on to get decent performance when we're using even like dynamic features like virtual method calls in C++. We often talk about, well, the compiler can probably devirtualize that. So this article from Arthur Dwyer just goes into just the right amount of depth into what the compiler actually can do. Obviously, it's going to vary from compiler to compiler what it actually does. Just give you just a bit more of a feel for when the compiler is likely to devirtualize something and when it probably can't. The one limitation to what the article goes into is that it doesn't take into account LTO, link time optimization. So that has like the whole program analysis view of things. So if things are going across translation unit boundaries, then what Arthur talks about here probably doesn't apply. And it's unfortunate, because that's usually where you're going to get most of the benefit from. But nonetheless, it goes into just the right amount of detail to be accessible, but also insightful. So that's what I always like about Arthur's articles.
Yeah, that's true. I usually enjoy reading his articles. I haven't checked this one in particular, but yeah, I think I should. It sounds interesting, really interesting. Experimental rabbit hole. That's just what I need.
Yep. So that is virtually the end, and actually the end for this month. So we should be back on track again for next month in March. As we mentioned a couple of episodes ago, if there's any news that you particularly want us to talk about in an episode, do let us know, and we'll try to incorporate it if it's appropriate. So thanks all for watching again, or listening, however you're consuming this, and we will see or talk to you next time.
Yeah, see you.